Our first lesson in chapter 8 is 8.1 is called complete the square. This lesson doesn't fully have you do the complete the square yet, but it's a review and the zero product property. So to get started with, I've got 4 examples I'm going to do here in the video for you. I would advise you to write these down as we go. Pause the video when you need to. For number 1, it's just plain x squared equals 20. And when we want to solve, we're asking what number times itself will equal 20. Well, then that means we have to do a square root. So I would then say that x will equal, and now we want to actually do both plus and minus, both roots, positive and negative. So the plus or minus square root of 20. And when I do this, I now have to simplify this radical of 20 like you did in chapter 7. So I need to think, are there any perfect square factors in 20? And yes, actually the square root of 20 does break into the square root of 4 times the square root of 5. And the square root of 4 happens to be 2. So when I write this to simplify it out, x is going to equal plus or minus 2 times the square root of 5. And that's all the further I need to go with that. So example 2. Example 2 is 5x squared minus 55 equals 0. So this is set equal to 0, and I need to solve for x. First thing is add 55 to both sides. So I now have 5x squared equals 55. I want to divide both sides by 5, so 5x squared divided by 5 leaves just x squared on the left side of the equation. 55 divided by 5 is 11. And again, now since I'm right back where I was over here at problem 1, I'm going to do the square root of both sides, so I can say that x equals plus or minus the square root of 11. So what I'm showing you in both of these examples here is that when you get down to a final answer, that you have to look for perfect square factors like we did over here. If you do, you simplify those out. Well, in number 2, there are no perfect square factors in the square root of 11 because 11 is a prime number, and 11 only has 2 factors, 1 and itself. So that means we will just stop right here at plus or minus the square root of 11. Let's take a look at 2 more examples. Here for number 3 of x plus 2 squared equals 18. So now on this one, I will right away again, I'm going to square root both sides. The square root of x plus 2 squared is x plus 2. We did a lot of that back in chapter 7. And that's going to equal plus or minus the square root of 18. Plus or minus the square root of 18. Now, I want to isolate x. So I'm going to subtract 2 from both sides. And I'll write this x equals, and then I'm going to put negative 2 plus or minus the square root of 18. Always put the rational number first, the irrational number, or the radical second. Now I want to take a look. Are there any perfect square factors in 18? Yes, there are. Actually, the square root of 18 is like the square root of 9, because that's your perfect square, times the square root of 2. So I'm just kind of writing this out here because you can see that mentally. And then I can say that x equals negative 2 plus or minus, well, the square root of 9 is 3, so it's 3 times the square root of 2. And now there are no more perfect square factors to factor out of my radical. Everything is in its simplified form, so therefore now I'm done with my answers. And I do need a minus sign underneath here. It's plus or minus negative 2 plus or minus 3 times the square root of 2. All right, last example, number 4, is this one right over here. I have these, I'm going to do the same thing. I'm going to square root both sides. So I'm left with 3x minus 1 equals plus or minus the square root of negative 4. Now earlier this year, had you seen the square root of negative 4, we'd have said no solution. Well, we won't do that anymore because if you're working 7-7 with complex numbers, we know we can deal with this negative on the inside of the radical sign. So first I'm going to start by saying I have 3x, and I will add 1 to both sides. So then that means it's a positive 1 here, plus or minus the square root of negative 4. Now I'm going to deal with this negative 4 inside the radical. So now I have 3x equals 1 plus or minus I times the square root of 4, as I know that to be the imaginary number, or the square root of negative 1. And now I know the square root of 4 is also 2, so I'm going to rewrite this as 3x equals 1 plus or minus 2i. Now I'm going to divide both sides by 3, and x will equal 1 plus or minus 2i, all divided by 3. At this point, you also want to see, is there a common factor in all three terms? If there is, if this said like 6 and 4 and 2, I could divide everything by 2. Now, if you have to make sure that if you're going to do that, that common factor is in all three terms. You have to have it in the first term, the second term, and the denominator. So at this point, I'm done because their only common factor in these three numbers is 1. Here's what I'd like for you to work on. Page 487. Numbers 7 through 25 odd is what I'd like for you to do. And the reason I'm giving you odd numbers again is so you can check your answers. So please make sure that you do that. Turn that in when you get done. All right, let me know how I can help you as you're working.